Hello dear aspirants, this is Dr. Sourav Sir's classes. Our contact number is 98367930076. Again, I am repeating our contact number which is 98367930076. And our email ID is souravsirclasses@gmail.com. So if you have any mathematical queries, doubts or anything, so please feel free to contact us. That means you can call on this number or you can WhatsApp also. So then our team can arrange a doubt clearing session for you. After that, you can join our regular batches, our one-on-one sessions, and our online classes. So that will be beneficial for your preparation of upcoming examinations like ISI, TIFR, CMI, NBHM, PUMDET also. So please feel free to contact if you need any help from us. Okay. So now we are going to solve a mathematical problem which is appeared in the year of 2024 in the question paper of PUMDET, and the question is telling us that the singular solution to the differential equation y equals to px plus p cube, where p equals to dy dx is, there are four options here, where our option A is telling us that 4y cube plus 27x square equals to 0. Option B is telling us that 4x square plus 27y cube is equals to 0. Option C is telling us that 4y square plus 27x cube is equals to 0. And option D is telling us that 4x cube plus 27y square is equals to 0. Okay. So what can be done here? So the given differential equation is what? That is y equals to px plus p cube. Okay. So where our p is equals to what? That is equals to our dy dx. Okay. So after that we can write this. So we are going to forming the first order partial differential equation. Then uh, taking differentiation of both sides with respect to x, we will get, and that will be ddx of px plus p cube. Then we know that our dy dx is equals to p, so that will be p here. So we will get uh, d yeah dp dx x dp dx. Okay, dp dx plus that will be p itself, because dx by dx that will be 1, and we will get plus p cube, so that will be 3p square dp dx. So p and p should be cancelled out, so now we will get x plus 3p square dp dx, that is equals to 0. Okay. So now we are going to find the singular solution. So for a singular solution, we solve for the envelope condition which comes from eliminating p using the original equation, which is this y equals to px plus p cube. Okay. So let me, now, so the clear out equation condition is obtained from the differentiating. We will get only this part, that is equals to 0. So from this we will have x equals to minus 3p square. Okay. So now we are going to substitute it in the into our given equation, which is y equals to px plus p cube. Then we will get, we are just putting the value of x in the given equation. Okay. This. So now let us take the value of p from the both of the sides. So we will get x equals to our minus 3p square. So we can write that minus p square by this P square equals to our minus x upon 3. So now in this, if we put this in this, then we will get that is equals to minus 2 into minus x by 3 whole to the power, that will be 3 by 2, because our minus p square is equals to x by 3. Okay, so now everything is under control, so we can write that our, from this we can write y is equals to 2 into x by 3 to the power 3 by 2. So we can write that y square is equals to 4 x by 3 whole cube. So that will be now 27y square, that is equals to 4x cube. And that will be, oh sorry, we will have some minus here. Yeah, let's check upon the options. Our 4x cube plus 27y square. I think I have did some mistake here with the minus sign also. Yeah, so that has to be plus, and yeah, minus from here, minus from here. Yeah, okay, so then that will be minus here. Yeah, so then everything will be correct. Minus 4x cube. So this thing will be plus. Yeah. So our 4x cube plus 27y square is equals to 0 is the correct option of this question. Okay. So our option D is the correct option of this given question. So again, I am telling that if you have any other mathematical query or doubts or anything, so please feel free to contact. Then our team can arrange a doubt clearing session for you. After that, you can join as a student to our institution. Then you can enjoy all the services of Dr. Sourav's classes. Okay, thank you guys. Hope you understood. Thank you.